Hello, my name is Gail Bermudez, and I'll be going over quiz number 5. The first question asks us to explain how to use the power series to estimate the value of e, and how many terms are needed to reach a point where the fifth significant digit does not change anything. So the first thing I did is to estimate the value of e, we used the power series that we are well aware of at this point of e to the x, where e to the x equals the sum from equals to 0 to infinity x of n over n factorial. However, for this one, since it is just to the first power, we replace x with 1 and get the, this following sum, which we can simplify since 1 to the n just equals 1 no matter what n, to simply the sum of n equals 0 to infinity of 1 over n factorial. Secondly, to find how many terms are needed to get to the fifth significant digit so that they're exactly the same, I first found out what the first 5 digits of ER, and then I made a little table where for each n in the sum, there is a what it would give you by itself, and then the total sum of all the ones before it plus itself. And I did this a few different times, and I got to that at the seventh n, we get the total sum of 2.7182, which is exactly the same as this e. The digits after it are not the same as the digits after this one. However, the first 5 digits are the same, so therefore it took 8 terms to get to the same 5 digits. The second question asks us to give the closed form and the power series of any function of our choice whose power series is centered at x equals to 0 and has a radius of convergence of 2. What I did for this one was that I didn't know how to start it, so I initially started with one I do know what it looks like. 1 over 1 minus x equals 2, the sum of n equals 0 to infinity of x of n. And I know that that one has a radius of convergence of 1. So what I did was that I wanted to get to something similar to this, but starting at the absolute value of x is less than 2. What I did is I divide both sides by 2 and got the absolute value of x over 2 less than 1, which we can then simplify to the absolute value of x over 2 is less than 1, since 2 is always a positive. Now this is the same as this. The, the only difference is that this looks a little bit different than this one. However, if we were to make y equals to x over 2 and plug that in, it'll basically be the same. So what I did was that I used this and plugged it in for where x is in both of these to get a closed form of 1 over 1 minus x over 2 is equal to the power series of the sum of n equals to 0 to infinity of x over 2 to the nth power. Thank you for listening.